Welcome back. This is Mr. Hassan's Maths channel, and this is the International A-Level Edexcel Pure Mathematics P4 paper from June 2022, question number 5, which is about integration by substitution. So first of all, it's asking us to use the substitution x equals 2 sine u to show that the integral between the limits of 0 and 1 of 3x plus 2 all divided by 4 minus x squared to the power of 3 over 2 with respect to x can be written equal to the limits between 0 and p, which we have to find, of 3 over 2 secant u tan u plus a half secant squared u with respect to u. So you have to show that this integral can be written in this form, not, before integrating. Actually, I think part B will be actually integrating this, but we can rewrite this in this form when we use the substitution x equals 2 sine u. So how do we deal with integration by substitution? Well, the key is for us to do the following. So our goal is to integrate this expression with respect to x. So the expression that we've got to integrate, I'm going to call it y. So this is 3x plus 2 over 4 minus x squared to the power of 3 over 2. I'm going to call that y. So our objective is to integrate y with respect to x between the limits of 0 and 1. And we have to do that using substitution. So what we're going to do here is we are going to take this and we're going to rewrite it as y, the integral between 0 and, well, I'll talk about that in a minute. We're going to integrate y dx du. If you rewrite it like this, this actually is the same as y dx. This, you can think of the du's cancelling out. But because now I'm integrating with respect to u, I have to change the limits. So I'm going to call this u1 and u2. The limits have to be in terms of u. You have to integrate everything with respect to u. So the y, which is this, has to be replaced. All the x's have to be replaced by u's. The dx du must be written in terms of u and the limits. So let's go on and just deal with the limits first. We have x equals 2 sine u. So we know when x equals 1, we've got 2 sine u equals 1. So that means sine u equals a half, which means u is equal to, that's going to be, we must use radians when we're dealing with integration and differentiation, and trig functions always radians. So that's 30 degrees, which is pi over 6 radians. And when x equals 0, you're going to have basically 2 sine u equals 0. So sine u equals 0, therefore u is equal to 0. If you try to find the inverse sine of 0, you're going to get 0. So I know my u1 and u2. So this is, we can say this is the u2 and this is u1. Okay, so we've got those values. Now we need to find what dx du is. Now we know that x equals 2 sine u, as we've written here. That means dx du is, if you differentiate that, you're going to get 2 cosine u. 2 cosine u. Okay, that's the differential of x with respect to u, dx du. So I can replace dx du with 2 cosine u. I can replace the u2 and u1 with pi over 6 and 0, and then I have to deal with this part here. So what I'm going to do now is I'll write the y part in terms of x first, and then we can deal with that when we've written it down here. So I'll keep this as 3x plus 2 over 4 minus x squared to the power of 3 over 2. So that's the y part. So that's the y part here. Then I'm going to have the dx du part, which is going to be 2 times cosine u, and then I'm going to write du. Okay, and I'm going to put, instead of 1, I'll put what the u value is when x equals 1, which is pi over 6, and instead of 0, well, it's going to be the same value. X is 0, u is also 0. So as we see here, anyway, so we've found the value of p. That's part of the question. Okay, now we have to show that this becomes that. How do we do that? Well, let's start off by doing something as follows. So we've got pi over 6 and 0. Now I can replace the x with 2 sine u, so this x is going to become, so it'll be 3 times 2 sine u plus 2 over, and this x can be replaced again by 2 sine u, so I've got here 4 minus 2 sine u, and all of that is squared inside there, to the power of 3 over 2, and I've got times 2 times cosine u du. Okay, so I'm going to continue here because I don't want to run out of space. So I have the integral between 0 and 6, pi over 6, sorry. Now this is going to give me 6 times sine u plus 2, and that's multiplied by 2 cosine u with respect to u. That's all over. Now this can be written as 4 minus, now if I square this, I'll get 4, because 2 squared is 4, times sine squared u. And that's to the power of 3 over 2. So we can continue simplifying this. So let's carry on over here. So now we got between 0 and pi over 6. So I'm going to multiply, I'm going to expand this bracket. So 6 times 2 is 12. That's going to be 12 times sine u times cosine u. Okay, and I'll have plus 4 times cosine u. 2 times 2 is 4. Yeah, that's right. So far so good. Okay, over, and this is, now what I can do here is I can take out a 4 as common from these two terms, and then I'll be left with 1 minus sine squared u. Okay, and all of this is to the power of 3 over 2. Okay, that's the same as 4 minus 4 sine squared u. And that's all integrated with respect to u. So now I'm going to have from 0 to pi over 6 again. Now this is, I'll keep this as it is because not much we can do with that. 2 sine u cosine u plus 4 cosine u. Now this, what I can do is I can split this up into 2 parts. This is like 4 to the power of 3 over 2, and 1 minus sine squared u. 1 minus sine squared u is the same as cosine squared u because of the identity sine squared a plus cosine squared a equals 1. So I can rewrite 1 minus sine squared of an angle as cosine squared of that same angle. So I can write this as cosine squared u, and this is also to the power of 3 over 2. They're both of them to the power of 3 over 2. It's like when you have a, if I have a to the power of a times b all to the power of something, it's the same as a to the power of that same thing times b to the power of the same thing. You can write them as separate powers like I've done here, because the whole of this is to the power of 3 over 2. Now, that gives us, we've got pi over 6. Still, it doesn't really look much like what it should do, but what we can do now is put 12. This is sine u cosine u plus 4 cosine u divided by, now 4 to the power of 3 over 2 is the square root of 4 cubed. Okay, this is 4 to the power of 3 over 2 is the same as the square root of 4 cubed, which is going to be, the square root of 4 is 2, 2 cubed is 8. So that's going to give me, that's going to be 8 times, and similarly the square root of cosine squared u is cosine u, and then cubed, that's going to be cosine cubed u. Cosine u or cubed is the same as writing cosine cubed u, and this is integrated with respect to u. So let's see now how we're going to continue. You have 0 and pi over 6. Now what I can do is I can split this up into 2 separate parts. Now I want to keep in mind what I have to show, and I've got that copied over here. And what I can do is I can just keep this in mind now. So you should always, when you get to this stage, just to check to see if we're going to get the right thing. So we got 12 and 8. Well, what I can do is write them as separate terms first. So 12 sine u times cosine u over 8 cosine cubed u plus, and this also can be written as 4 cosine u over 8 cosine cubed u. Now I can need to put a bracket there because they're separate terms with respect to u. Now let's see what happens. Let's see if we get what we want. You got pi over 6 and 0. Now 12 divided by 8, well, that gives you 3 over 2. Divide by 4, divide by 4. So you got 3 over 2, which is what we want. Now this cosine u and cancels with this cosine u, so you're going to get cosine squared u. So I can write this as sine u over cosine u times 1 over cosine u. I can split that up into two parts. And then I've got plus, and the 4 over 8 is 1 over 2, which is what I need. And the cosine u and the cosine cubed u cancel to give you cosine squared u. So you're going to have 1 over 2. I can put this as a cosine squared u in the denominator, and that's integrated with respect to u. And that should finally give us exactly the same thing as we have written, or we had to show up here. So you have 3 over 2. Sine u over cosine u is tan of u. 1 over cosine u is secant of u. So it's the same thing, just written the other way around here. And I got plus 1 over 2. And 1 over cosine squared u is secant squared u with respect to u. So here we've shown all the steps very clearly, and we've ended up with exactly what we had to show. And we can even say here p is equal to pi over 6. And that gives us the answer to part A of this question. Okay, so it looks at some stages here like, what are we doing? But you just have to keep, if you follow this method here, it always works out with this substitution. Always works out. You have to just make sure you don't make any silly mistakes, and you just follow all the way through, and you'll realize you get the right answer in the end. And if there is any mistakes you made, there's plenty of pages for you to continue. I think this type of question, they give you a lot of pages, so I think even the next page is blank for you. You can carry on and write here. So I'm going to go on to part B now, which I've got ready over here. So part B says, hence find the exact value of this expression, and this is what we had to show, and that's how we're going to start off with. And this is basically, so hence means use your answer. P is pi over 6, so we can use that, of course. So now what we're going to do is we're going to integrate this expression with respect to u. Okay, now this is a pretty simple one, because these are some of the kind of standard integrals. Okay, and if you don't know these integrals, you can find them in the P3 equation booklet, the formula booklet, under differentiation. Under differentiation, we know they tell us that if f of x is secant x, then f dash of x is basically secant x times tan x. And they also tell us if f of x is tan x, then the differential of tan x is secant squared x. And we can prove these actually, by using what's called the chain rule. It's possible for us to prove that this one with the chain rule, this one with the quotient rule, sine x over cosine x. You can use a quotient rule to prove this integral, but no need to do that here. But these are standard integrals that you find, standard differentials that you find in P3. So the opposite applies. If secant tan x is the differential of secant x, then the integral of secant tan x is secant x. If sec squared x is the differential of tan x, then the integral of secant squared x is tan x. Okay, so these are standard integrals here. So this I can straight away integrate. This is 3 over 2, this of secant u, and this is plus a half of tan u. Simple as that. Okay, and the limits we are going to use are pi over 6 and 0. So now all we have to do is substitute these values in. So you got 3 over 2 times secant. Now I'm going to write secant as 1 over cosine. So it's going to, I'll put this as 3 over 2 cosine u, because it's easy for us to think of things in terms of cosine when we're finding values. So I'll put this as 3 over 2 cosine u. I'll just write it like that first before we continue. Plus a half tan u. That's tan u is fine. We can find that easily. That's pi over 6. So you're going to end up here with, if you now put the values in, you're going to have 3 over 2 times cosine of pi over 6 plus 1 over 2 times the tan of pi over 6. Now don't forget the 0. Now the 0, so a lot of students neglect to put that in, thinking that this is going to cause everything to become 0, but it doesn't. Okay, because we know that the cosine of 0 is 1. So this is 3 over 2 times the cosine of 0. And you're going to have plus a half times the tan of 0. Well, the tan of 0 is equal to 0, but the cosine of 0 is equal to 1. So that's going to be, there's going to be something there that we have to use, so that don't make that mistake. Now the cosine of 30 degrees is pi over 6 is root 3 over 2. So you have 3 over 2 times root 3 over 2. Those will cancel. So it's 3 over root 3 plus 1 over 2 times. Now the tan of pi over 6, okay, you can just work that out. The tan of pi over 6, let's change this to radian mode. Okay, so it's in radian mode, so we're going to have the tan of pi over 6. I could have put 30 degrees, but no problem. And that is, if I remember rightly, I think 1 over root 3. Oh, yeah, it's 1 over root 3, which is the same as root 3 over 3. In simplified third form, that's root 3 over 3 minus 3 over 2. Minus 3 over 2, because cosine 0 is 1, so that's 3 over 2. Okay, so now we're left with, now if I rationalize this by multiplying both top and bottom by root 3, I'll end up with 3 root 3 over 3, so that gives me root 3, plus root 3 over 6 minus 3 over 2. So this is like, you can say, this is like, you could say 6 root 3 over 3. Okay, root 3 over, yeah, that cancels out. 3, that's right. So this is root 3 plus root 3 over 6 minus 3 over 2. How do they want us to give the answer? The exact value. So I want to give it an exact surd form. So to simplify this, what I'm going to do is I'm going to call this 6 root 3 over 6. So I'll end up with 7 root 3 over 6 minus 3 over 2. And to make it even neater, I can make this into something over 6. So 7 root 3, okay, and that will be over 6, making that into 6. So 7 root 3 minus 9 over 6. That's now in simplified surd form. Okay, so 7 root 3 minus 9 over 6. And there's the answer to this question. Now, supposing I want to check to see if my answer is correct. Supposing I want to check to see if my answer is correct. What we can do is we can go to the original equation here. We can stick this into our calculator. Okay, and we could even do the same with this actually. But you could do the same with this, but you'll have to use tan u over cosine u, and you'll have to put secant 1 over 2 cosine squared u. But we can do this. We can do it with this even. There's no problem. We can do it with this. We can put our fraction 3x plus 2 in the numerator over, we got 4 minus x squared, close that bracket, to the power of 3 over 2. Okay, and we got the limits as 0 and 1. And when we press equals, it gives us 0.5207. So let me store that as A. Okay, that's stored. So hopefully what we've got here will give us exactly the same value. So let's see, we got 7 times the square root of 3. Let me just put this under 1. 7 times the square root of 3, okay, minus 9 all over 6. And that gives us exactly the same value. Okay, that's exactly the same value that we got, and with this 0.5207, and this was the answer we got in, well, this was the answer that we got with the integral. Okay, this was the answer we got with the integral when we finished it, and that's exactly the same value, okay, that we had, which was, as we said, 0.5207. Okay, so and that's how you can check your answer. Okay, you see you got exactly the right answer. Whatever this is equal to is what we got. Okay, but we have to write ours in exact form. We don't write it in this form. Okay, so that's, you know, one way you can't just write down the answer that you got from the calculator. This is what the calculator gave you when you did this integral directly from the calculator. It didn't give you the exact form, right? So that's a clue for the examiner. If you write down this correct answer without showing any steps, you just put it in your calculator to get it, and of course you won't get any marks for that. So you have to show the steps. Why do I show you how to do it on the calculator at the end? Because if you have time in the exam and you want to make sure you haven't made a silly mistake, you could have made a silly mistake anywhere. For example, if you forgot this, you didn't put 0 in here and you just left it with these two terms, then you could have realized that, oh, maybe I've done something wrong. You can check back, oh, I'm supposed to do that, and so on. There's plenty of places where you can make mistakes. Okay, and the other thing to realize is part A and B, they don't really depend on each other. The only thing that you need from part A really is to know that this is pi over 6. But if you were, for example, didn't get it pi over 6, or you got it as another number, and you integrated everything correctly, you would have got like the majority of the marks for the paper, or for this question, okay, which is 4 marks. You would have got the majority of them. So if you can't do part A of a question, don't always ignore part B. Try and see if you can do it. In most cases, you're given the tools to be able to do it. So that concludes this question here from the paper, which is this paper, which I didn't write over there. Pure Mathematics P4, June 2022, International A-Level. Other questions from this particular paper can be found in the playlist that will appear in this region here. Other questions from Integration by Substitution from P4 in the playlist over here. And you can subscribe to my channel by clicking on this link over here. Thank you for watching, and see you soon.